Okay, so we've got a question here that is asking us to work with a right angle triangle, and it's given us two lengths and it wants us to find the third length BC. So a right angle triangle with two lengths given to find a third side is always shouting at us, please use Pythagoras. So Pythagoras theorem, again, it's like all rules and formulas, it's best to write it out. So I'll look at a little picture with the right angle triangle, A and B being the short sides and C being the long side. A squared plus B squared equals C squared, and it's really important to take care. C is the hypotenuse, the longest side. So it's really important we get that. Excuse me. So it's really important we get that in the right place. So we can now replace our values. So A equals 6, B equals the length of BC, and C equals 13. So we can replace the values in the formula. A squared plus B squared equals C squared. So we have 6 squared plus the length of B squared equals 13 squared. So B squared is equal to 13 squared minus 6 squared. So again on our calculators, 13 squared, take away 6 squared, so 133. So B equals the square root of 133, which is 11.532. Then we recognise the question said it wanted the answer to 3 significant figures, so therefore it's 11.523 significant figures. So we just have to watch for that and be careful. The next part of the question talks about another right angle triangle with two lengths on it. If it was asking for the third length again, this would be a double Pythagoras question, but we can see that when we read the question carefully, it actually wants us to find the angle RPQ. So RPQ, we go RPQ, so RPQ is this angle here, so label the angle, theta. So that's the one we've got to find. So car tower, whenever we see trigonometry questions, that's the kind of thing that we should be writing down. They don't give us the formulas in the exam, so we go through the process of labelling the triangle. So this tells me to label the triangle with O, A and H. So there's theta. The opposite side to theta is here. This is next to the angle, so that's the adjacent side, and this is the longest side of the triangle, so therefore it will be labelled H, the hypotenuse. Now the question wants the angle, so under SOHCAHTOA we can tick A because we know it, and we can tick H because we know that as well. That's the only one we've ticked twice. So we use cos theta is equal to A over H. So again, we fill in the values that we know. So we don't know theta, the angle, but we do know the value of A. We know it's 17, and we know the value of H is 25. And to get the angle, the opposite of the cosine function is the inverse cosine function. So theta is going to be the inverse cosine function, which on our calculators is cos to the minus 1. And it's going to be cos to the minus 1 of 17 over 25. We must check the calculator is in degrees mode. So we check the calculator is in degrees mode. That's really important, so it's something to watch out for. So we get our calculator, yep, the calculator's in degrees mode. So second function, cos to the minus 1, so that brings up the cos minus 1 function. Bracket, we're doing 17 over 25, so 17 divided by 25, close the bracket, equals 47, so that equals 47.156, and to one decimal place, because the question said write the answer to one decimal place, so I've got to watch for that as well. The 5 changes the 1 up, so it becomes 2. So it becomes 47.2 degrees. So again, right angle triangles, we should be thinking Pythagoras Trigonometry possibly, particularly when it starts talking about lengths. We've got two lengths given, so Pythagoras. And then on the other triangle, we were given a right angle triangle, we were given two lengths and we had to find an angle. So when you involve an angle, you have to use trigonometry. So SOHCAHTOA is written down, label the triangle up, tick underneath what we know. We knew an h value, we knew an a value. The only one we could tick twice was the cosine function, so that's the one we had to choose to use. When we want an angle, then we do the inverse cosine function to get the actual angle out. We must check our calculators in degrees mode to get the final answer. So that's Pythagoras mixed with a little bit of trigonometry.